Hi, my name is Noah Gift, and today I'm going to talk about data science for infrastructure, or monitoring and logging and instrumentation is what most people call it, but I call it data science for infrastructure. And the reason is that many data scientists are now getting into building data engineering applications, machine learning applications. I call this full stack data science. And as a result, they need to learn how to debug their systems, how to get into potentially the infrastructure, the cloud, figure out why things aren't working. These are all things that we can take care of by using the data science principles, but for the cloud infrastructure or for the data center infrastructure. So really, monitoring and logging is another form of data science. It's just a data science that many data scientists themselves have not been exposed to. So let's go ahead and get into some of the principles based on a lecture that I did at a university recently. Let's take a look at the concept of Kaizen, which is Japanese for continuous improvement. Really, it's a feedback loop. And this is the basis of building anything that's meaningful, anything that's complex. And one of the things that I think is the most important for anybody to remember when they're building a software system is this concept of, does anything work? If it does not, then you go and you simplify things. And this is probably the most common problem I see for data scientists that are new to software engineering, is they're not simplifying enough until they get to the point where it's so simple that it works, and then they incrementally add things. So there's a lot like, before you build a, advanced chocolate sundae that has, all these different characteristics like hot fudge and whipped cream and everything else you're going to put on it, you need to get the basics down. You need to get a bowl, you need to put some ice cream in it, get that working first, right? That's really the foundation before you can build something complex. Once you've done that and you verify that everything works here, the next thing to do would be to decide what ingredients you want to put into your data science project. So it could be some pandas code, that could be an ingredient. It could be natural language processing, either an open source or proprietary system. Maybe you could add a big data system like Google's BigQuery, or Amazon Athena, or maybe one of the Azure data factory systems, some kind of big data system. Sprinkle a little bit of that in, or you could add an AI API. So this is really the feedback loop, right? Is get something working. If it doesn't, simplify. Once you've got it simplified, then you can add these advanced ingredients, and this makes the sundae. So really, this is the foundation of thinking about monitoring and infrastructure. Now let's move on to some examples of feedback loops. We see this all the time in nature, right? We have plants. The plant, you put it into the ground. It needs water, sun, soil, wind. And if you don't do this, it's going to die, right? And this is something where you can't have a plant that grows, extremely well for a little bit and then leave it alone. Either these conditions constantly need to be addressed so that the plant can respond to its environment, adapt, get stronger. And this is a feedback loop in nature, right? It's continuous improvement or continuous destruction. You see the same with exercise. If you're going to join the NFL and you're going to get really strong before the season, you can't stop being strong. You're going to need to maintain that strength and then in the future continue to build on it, right? This is a feedback loop. That's not how the real world works. Organically, you're either getting better, you're the same, or you're getting worse. And this is really the essence of a microservice. And a full stack data scientist, this is what I would recommend you start with. You must get this down, right? Put your code into GitHub, test it, lint it, deploy it, get some kind of continuous integration working, add new features once you've got this working, and continuously deploy this to the cloud. And then also you want to have monitoring and infrastructure instrumentation so that you know what's happening. And this is the feedback loop, right? So this itself is one feedback loop, but then there's a larger feedback loop, which is you have the ability to look at the CPU, the disk I/O, the application logs, and then respond and adjust your application based on that. And I think this is really not taught enough in terms of data science, is that, hey, we love data science. We love using statistics to make decisions, but we're not using data science techniques for cloud computing. And this is why there are some problems with deploying data engineering and machine learning applications. So moving on here, this is what I would call the foundations for data engineers and ML engineers. You must have DevOps, and that's what I just described: microservices, continuous integration, continuous delivery, monitoring, infrastructure. Once you've got that working, then you can move on to operationalizing your data. So creating data pipelines, making sure that data is cleaned automatically. Next up would be making sure you're using the platforms that are available, like Spark, SageMaker, Azure ML Studio, Google, Vertex AI. Once you've done that, then you're at the place where you can do ML ops. And so this is an important consideration, is that you can't do any of these more advanced operations without first mastering DevOps. And my recommendation is every single data scientist should know DevOps, because it's fairly straightforward and it's only going to be helpful. It would be like, telling someone they shouldn't know about basic statistics and probability. We know that that's not true. In fact, we're seeing many people making incorrect choices about vaccines, for example, because they don't understand basic statistics. Same for data scientists. We need people to understand DevOps. It's only going to make things better. So if we move on here and we think about monitoring and logging, I think the best way to describe this for a data scientist, especially one that is doing full stack data science, is that it's data science for the infrastructure. And what you need to do is think about things in this, this sequence right here. We have 1, collect the logs. So you need to be collecting data just like in a data science project. 2, we need to centralize the data. Again, imagine you have several pandas data frames. You want to merge those data frames together so you can do some operation. Likewise, you need to have all of the logs in one place so you can do something with them. You need the ability to search those logs. And that could be anything from open source Elasticsearch solutions to Splunk to AWS CloudWatch to Google Stackdriver to third-party systems like New Relic or Datadog. But the general idea here is that once you have all these things together, collect, centralize, search, you can report on it. And this is data science for the infrastructure. And inside of here as well, there are some real tricky problems that happen in infrastructure that are almost impossible to debug without some kind of data science for infrastructure. And so, in this case, let's say there's a load balancer, there's a load balancer, there's a load balancer, there's a load balancer, and they're all available in an API. You could have some intermittent client error, which I've had before, where maybe 1% of the requests have a problem, and it can be very difficult to debug because maybe one of the leaf nodes here has a problem, and you don't know that unless you've collected all the logs here and have some kind of alerting system that looks for what's happening on particular nodes, and you can dig into it and realize, somebody accidentally manually overrode our automated continuous delivery system and deployed some bad code there. And I've actually seen this before, where someone manually patched a change onto one server to fix it and forgot about it and then left it there for a year. And then there was a problem where it was such a big system, we couldn't tell what the issue was without better logging and instrumentation. So what are the kinds of logs that you'll see in a system? Well, you have the system logs, right? This is, Linux, for example. You would have what's going on with the operating system, the kernel. You also have application logs, and these logs would be things like the logs you would write in your microservice. Like, for example, here's the customer's UID, here's the item the customer purchased, and here's potentially the production database table that this log is writing to. All things that can help you have breadcrumbs so you can come back and link things together and find out what's happening. Now, what do you monitor? Do you want to monitor CPU? Do you want to monitor disk I/O? Well, yes, you want to monitor all these things: storage capacity, latency of a web request, the accuracy of a machine learning model. These are all the kind of things that are really critical to log in your infrastructure. And so really, in a nutshell here, I think the main takeaway is that, if we go back to this, it is that monitoring and logging is data science for the infrastructure. If you're a data scientist, you should care about this, just like you care about the other kind of data science techniques that you're using in your everyday life. So my recommendation is get started with monitoring and logging. There's lots of good examples. There's a couple books that I've written recently for O'Reilly, Python for DevOps, and also Practical MLOps, that go into details about how to monitor and log for full stack data science.